Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikmal and I'm Halim. My metric number is 01DDT20F057. Right now, we'll be discussing the case study for DBM20083, which is discrete mathematics, regarding the topic graph minimum spanning tree, or short form is MST. Moving on. As for the introduction, what is a minimum spanning tree of MST? A minimal spanning tree is the subset of the edges of a connected weighted undirected graph that connects all the vertices together without any cycles and with the minimum possible total edge width. In this case, it's especially useful for optimizing routes in scenarios like travel planning, which the one that we will be discussing later. Ensuring minimal distance when visiting multiple cities, and other examples such as network design, which is creating efficient layouts for roads, power grids, or communication networks. Lastly, cost reduction, as for minimizing expenses in projects involving connected structures. Those are just some of the real-life applications implementation and in implementing minimal spanning tree. Moving on to the next thing.
Hai, Assalamualaikum. Nama saya Muhammad FAIZ bin Muhammad KAMAL. Nombor matrik 01DDT22F8016. Untuk hari ini saya akan explain the case study discrete math for the technique prim algorithm. So in the case study, prim algorithm is used to find the most efficient route connecting all 15 cities with minimal travel distance. Starting from any city, the algorithm build a minimum spanning tree by adding the shortest route to unvisited cities. This continues until all cities are correct and show the least total distance traveled. So for the point 1, start from any chosen city in nature vertex. Second point, select the shortest route edges connecting a city in the minimal spanning tree to an unvisited city. The third point, add this route to the minimum spanning tree. And the last point, repeat until all city vertices are part of the minimum spanning tree. Thank you for me. Let's continue.
Assalamualaikum warahmatullahi wabarakatuh, and a very good evening. My name is ABDULLAH HARITH bin MUHAMAD LATIFFI. My metric number is 01DDT22F2074. As you can see, I did the weighted graph as shown below, where I have 15 vertices and 30 edges across all of it. And as you can see from we have weighted we have number on the graph to tell that it is a weighted graph based on the question. And this is my calculation, which I use the Prism method. The Prism method is much easier for me to obtain because I don't need to cross it without skipping anything. As you can see, the Prism method, the edges and the weight, where KL Kinta, the weight is 15. KL to Kinta, Kinta to station 18 is 18 in weight. Kinta to station 18, station 18 to Cyberjaya 14. Cyberjaya to Lata Putih, as you can see here, 18 of the weight. Lata Putih to Ulu Kinta, Lata Putih to Ulu Kinta, the weight is 16. Cyberjaya to Kinta here, the weight is 14. Kinta to Shah Alam, the weight is 18. Shah Alam to Lenggong, as you can see, Shah Alam to Lenggong is 14 in weight. Kinta to Kuantan, as you can see here, Kinta to Kuantan, the weight is 16. Kuantan to Padang, where the weight is 18. Padang to station 15, which the weight is 16 here. And last but not least is Kinta to Air Keroh, where the weight is 32. Where is Kinta to Air Keroh? Kinta to Air Keroh. Here, Kinta to Air Keroh. This is the total weight that I got, which is 15 plus 18, 14, 18, 16, 19, 14, 18, 14, 16, 18, 16, 19, 22, equal to 237. How do I know that I need to choose 14 vertices, 14 edges across the graph? So the way to do it is I calculate how many vertices that I have, and I need to minus 1, which is, in this graph I have 15 vertices, so I need to minus 1, which is 14 vertices that I need for Prism method to be applied, as you can see here. And as you can see here, all the graph that have been go through by the user, by the people that need to use it. The red indicate that the edges is being used as the Prism method.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin RADZI. My matrix number is 01DDT22F all for 6. I will continue as calculation. The minimal spinning tree is created for authorizing part in the world. Implementation such as a design infection transposition route, minimizing the lack of revealing a network setup. Road networks is a new areas by reducing the total distance or cost required to visit all cities. Traveler can maximize their time and reduce the travel expensive (MSTS) issue. The resources are used efficiently without unnecessary repetition or access. That's all. Thank you.